Welcome to Season 2, to Episode 9 of Tech Talk Thursdays. The rapid pace of new products, product integration, and miniaturization is driving the need for a better understanding of materials, equipment, and processes at the device level. The Integration Focus Group produces an annual roadmap to address the many challenges facing OSATs and manufacturers. My first guest today is Bill Bottoms, Chairman of the Heterogeneous Integration Roadmap. And later, I'll be speaking to Rosalia Baker from AT&S, who sits on the committee for wafer level and fan-out packages. That's our topic today. Let's join our guest, Bill Bottoms. Heterogeneous Integration Focus Group is a continuation of the work formerly undertaken by the ITRS Group, which disbanded in, I think it was around about July 2016, as we discussed earlier. Here to discuss this topic is Bill Bottoms. He's chairman of the HIR, and he's here to tell us a bit more about the efforts of the Heterogeneous Integration Roadmap. So welcome, Bill. Thank you for joining us today.
Thank you for having me.
Yeah, so let's start out by telling us what is heterogeneous integration and why is it important?
Well, heterogeneous integration is when you combine things that are different in some way, and they may be different by the feature size of elements that are incorporated in them. They may be different by the materials that are used to build them. They may be different by the location in which they're built. So you incorporate things that are different into a single element, and they're different, so they're heterogeneous. The reason you do it is that we can build something better when we have something that needs, for example, to deal with photons, we have to handle that with a wide bandgap semiconductor so the photons can be transported. Mm-hmm. If it deals with electrons, we have to handle that with metals, and photons don't travel in metals. And so the combining of those is the key to heterogeneous integration. And we have to integrate in that way so we can separate the world of photons, which have some wonderful characteristics, from the world of electrons, which have some wonderful characteristics, and they're different, and have them still as close together as we can, both in size and in functionality.
Okay, so I mean, a lot of your efforts here are working towards what's contained in a system in package, an SIP device. So you're trying to combine these functionalities and materials all into a very small area, as it were. Can you explain some of the activities that you're doing in that area?
Okay. Well, first of all, let me say that the reason we want it to be system in package is we want it to be lighter. We want it to take less power. We want it to operate better. And that means all of the transistor elements need to be as close together as possible. And if we can put them in the same package, then the wiring is as short as possible, and we get a better result of the function that element would be able to deliver if it were not integrated closely into a system in package.
Right. Okay. Now, one of the areas obviously you must come across in this is potential CTE mismatches. What sort of steps do you take to try and mitigate these?
Well, CTE mismatch is one of the significant issues that has to be dealt with, particularly since our semiconductors now are very thin. We thin them to a level where you could wrap a piece of silicon around a 2 millimeter mandrel. It doesn't break because it's very flexible when it's thin. And that makes everything smaller. One thing we do is we try to remove the mismatch by changing the characteristics of one of the materials. And the biggest mismatch is between the dielectrics, the insulating materials, whether it's printed circuit board substrate or whether it's silicon dioxide, it doesn't matter what dielectric it is, and silicon, and metal, and that difference, copper is 17, silicon's about 2, I've left off the 10 to minus 6, and we have to do something about that. If we can, we actually can. We can make a material as a composite material, which drops the coefficient of thermal expansion of copper from 17 to about 4.5.
Wow, that's incredible. I mean, that's quite a drop. So tell us how you achieved that.
Well, to some degree, it's a heterogeneous integration. It's a composite material that's made by combining a material that has almost no thermal expansion, almost zero, and that's a carbon nanotube, with copper that has a lot. And we combine them in a way that the copper is very firmly bonded to the nanotubes that are incorporated in the structure. When they do that, they transfer their properties. And the properties are better electrical conductivity and lower thermal expansion. And so we can build a composite copper by doing that. And the way we build it is we plate it from a bath, and it works just fine. And it's not in use a lot today, but it will be used more and more as we go along.
Okay, great. So let's talk about the roadmap in itself. I mean, how many members do you have involved in this project and defining it?
Well, there are a total of 23 chapters. I would say that each of those chapters has at least 30 people contributing. There are more than that contributing, but the ones that contribute enough to get their name on the masthead is maybe about 30. But you know, you multiply 20 by 30, it's a large number.
A large number of people.
And the people that actually participate in the workshops, where we do collective work to find out what new problems and potential solutions might be, that number is in the thousands. We have workshops around the world. We used to have workshops around the world, and hopefully we will be able to have workshops around the world again, because it's much more effective. It's more effective than just doing it online. And there you can read body language, and you can tell somebody wants to say something and maybe they're shy. It's a little hard to do that when you've got 40, 50 people in a Zoom meeting.
Yeah, exactly. Wow. So what is the timeline then for the publication of the roadmap?
Well, the 2020 roadmap edition has been published. Work on the 2021 edition, yes, it was released earlier in the year, and work on the 2021 edition is well underway. We hope to have the 2021 edition published in late the fourth quarter of this year, or early in the first quarter of next year. And it will have the same 23 chapters. It is likely that there may be one or two more chapters. For example, we didn't have much treatment about quantum logic in the previous one, and we're adding that. And whether we make it a subchapter or a separate chapter, we haven't decided yet. But as new developments like quantum computing come along, we try to put them in place and identify the problems. For example, to make the quantum computer work, it has to be very near absolute zero, less than 1 degree Kelvin. It's not cheap to do, and it's not easy to do. And if you put data in and take data out, it requires some energy to do that, and you still have to keep it at that temperature. The problem that we'd like to attack in that space is maybe raise the temperature by about 30 degrees absolute.
Okay.
That's cheap. That's cheap to do. It's not hard to do. You can do it by just pumping a little bit on liquid nitrogen. You don't have to pump on liquid helium to do it.
Right, exactly.
And so that's one of the challenges that's out there. Roadmap identifies it. We need to move it. The 30 degrees is just an arbitrary number. The problem gets so much easier. It's not a linear function getting away from absolute zero. So 30 degrees is enough. It's just easy to do. If we could do it at room temperature, temperature would be even easier.
Even easier, yeah, absolutely. Well, it seems like you've got a huge amount of work on your hands. We're going to be talking later this evening, actually, to Baker Rosalie, who's a member of your committee, and she'll be telling us a little bit more about some of the work that's involved in that. But for now, Bill, I want to thank you for joining us.
Well, thank you very much for having me.
Big data, artificial intelligence, and smart factory solutions are here now. Automated optical inspection is critical in a smart factory environment. Leading the way to Industry 4.0, Murtech invites you to the smart factory of the future.
And welcome back. I'm joined now by Rosalia Baker from AT&S in Austria. Nice to see you, Rosalia. Thank you for joining us today.
Thank you, Trevor. It's really a great pleasure to be your guest today.
Thank you. So before the break, we were talking to Bill Bottoms, who's, of course, the chair of the Heterogeneous Integration Roadmap. But you work on the committees, and I think specifically you work in the areas of fan-in and fan-out devices. Can you tell me a little bit about some of the work you're doing there?
Sure. So I'm chairing the technical working group for fan-in and fan-out, and actually I have the great pleasure to co-chair that working group with John Hunt from ASE. So together with John and also with a group of members across the entire supply chain, members from market research to your development to research institutes from Fraunhofer, for example, in Germany, ACE in Japan. We have material companies, Shimizu, Japan, Dow, in US. We have Indium, also representative from Malaysia. We have Xilinx from US. TSMC has also helped us. We have the OSATs, we have the MCOR and ASC. I hope I don't forget someone, quite a group.
So, yes, sorry. That's quite a combination of different suppliers that you've got there, people that are providing equipment, materials, trying to get them to work together. What challenges are you looking to try and resolve?
So we are looking from the application perspective and also from the integrations of the different integration technologies to use for both fan-in and fan-out. So in terms of fan-in going to heterogeneous integration, there are not necessarily that many let's say options. At this point is more the fan-out that will enable heterogeneous integration. And when it comes to fan-out, it's definitely a very hot market today. Can address the lower end if we look at PMIC, baseband, codec, audio, lower end devices, going to more on the mid-high end on the application processor, and certainly TSMC entering in that market with the info technology has made a big impact. And then there is more development and actually some in production as well, looking at the ultra high density fan out. So ASE, just to bring ASE's technologies fan out chip on substrate, which now that I'm at AT&S, we also have a version fan out system in board. So we are looking at, as part of the heterogeneous integration, of how the different applications are impacting the needs. We try to put the roadmap and forecast on how the technology will change with respect to the more the critical parameters, and what are some of the challenges that will still need to be solved.
Right. So you're looking at this, for example, from the materials point of view, for seed mismatches, etc.
Yeah.
You're looking at it from the the practical point of view for roughness and how materials perform. What else are you looking for? Are you looking at the process as well?
We are looking at processes as well. And now that I remember, we also have SPTS Orbotech, which is K-Late Anchor now. So from the equipment side, that it's part of the committee, and very good input from them as well as from Fraunhofer in looking at also the infrastructure. So not only how we do this type of system in package using fan out on the wafer side, but also on the panel side. And there is quite a lot of interest in the industry moving from a wafer type infrastructure to the panel for cost reasons. Yeah.
Right, of course. Well, I mean, you're actually working at AT&S, which is a large PCB manufacturing company. What opportunities do you see specifically for AT&S there with heterogeneous integration?
Yeah, so heterogeneous integration today, and even more so in the future with all these different new applications. If we look at 5G, if we look at artificial intelligence, high performance computing, data centers, it certainly brings a lot of opportunities, I think, to the entire industry. But if we look, at the chiplets and in general, trying to bring more functionalities within the package, looking at the higher, especially at the higher end, the GPUs, more data, more storage, more processing, all these will require a substrate. So for us, actually, it's a really good time. And we are currently a $1 billion company, and we are significantly investing in IC substrates, and in a couple of years we'll double our revenue. We are looking at different technology to support the industry in terms of all these higher end devices that today you can't really find them packaged individually. So they are either manufactured as a chiplet but still packaged within a system using heterogeneous integration. So from that perspective, it's certainly, like you mentioned before, the material integration will be very important. In our case, I will take it even one step further. We have developed different type of technologies to integrate the layers and build these substrates. Also embedding technologies, 2.5D cavities that we can actually bring. We call it a toolbox, that we bring all these different technologies within one system. So, right. That's also heterogeneous integration.
Well, as a form, I guess, but you've certainly had a very wide experience across the industry, because you worked in the front ends for a little while. You've worked with Applied Materials, did some work with Dow, and now you're with AT&S. So in technology terms, you've literally gone across the whole gamut, really.
Yes.
So makes you a very special place. No, it's interesting. I mean, the industry is definitely expanding by application. It's exploding, really, and the speed of new product integration is just making things very, very difficult. But also the miniaturization. The miniaturization is, of course, creating a lot of noise on these packages and substrates. So I guess heterogeneous integration becomes more and more important as things get busier and get smaller.
Yes, that's correct. So we do have programs that specifically focusing on miniaturization with respect to, for example, how we can further reduce the line and spaces, make even denser features. So we already have in production today, it's below 10 micron line and spaces, but in development, and we have demonstrated already down to 5 by 5 and working even beyond that. Mm-hmm. So that's certainly one aspect of miniaturization, but then also enabling our customers with some of the embedding solutions. So instead of having them, for example, on the top of the board, we do embed them inside the board that will give them space on the board, or miniaturize the board to help either with the thickness or maybe more space for the battery or for other functionalities to put on the board.
Right. Yeah, it's a very fast changing world, and although we're all caught up in this COVID pandemic at the moment, I think once we get out the other side of that, it's only going to accelerate even faster in terms of product introduction. Yeah. Anyway, it's wonderful to hear the work that you're doing with the HIR, and of course, if people want to find out more information about it, is there a website they can go to, or where would they find out more information on it?
Yes, we actually have a website. It's part of the Electronics Packaging Society. I don't remember now exactly the link, but maybe I can send it to you. No. Yes, we do have a lot of information, and we are open and welcoming new members, not only in the fan-in and fan-out committee that I'm chairing, but across the entire heterogeneous integration. Is I think it's a great opportunity to work with industry experts, to learn from them, to share information, and to help the industry. We are trying to put the roadmap together, and we need definitely more help, new members.
The more contributions, the better. Yeah. But anyway, it sounds like you're doing some very exciting things, and I want to thank you, Rosalia, for joining us today.
Thank you so much, Trevor. It was a great pleasure speaking with you. Thank you.
Well, that's it for this week. Thank you for watching. Stay safe and have a great weekend.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.